There's an electric car in development that could completely change how people over 55 view automotive retirement, and the leaked figures about it are putting the market on high alert. Rumors point to a Tesla Model 2 with a suggested starting price of $12,149, a value that seems almost unreal when compared to any other electric vehicle ever launched by the brand. Deliveries are scheduled for the end of 2026, and what's most striking is that this model wasn't designed to appeal to tech enthusiasts or speed lovers. The proposition goes in a completely different direction from what the market usually expects from a launch by the American automaker. The focus, surprisingly, is on an audience that rarely receives dedicated attention from the modern automotive industry. The strategy behind this project involves an observation that seemed obvious, but that no one had turned into a product until now, and the engineers responsible for its development thoroughly studied the financial behavior of more experienced drivers. It is estimated that people over 55 years old spend an average of $9,400 a year just to keep a gasoline-powered car running, including fuel, oil changes, periodic maintenance, tires, and unexpected repairs. This amount represents a considerable portion of the income of those who are nearing retirement or have already retired. The central idea of the Model 2 is not to deliver sporty performance or offer refined luxury, nor even to compete with Tesla's own premium models. The stated objective is to drastically reduce the total cost of ownership over the years, transforming the car into a financial ally instead of an ongoing expense. To understand the magnitude of the disruption this launch represents, one only needs to observe how the automotive industry traditionally treats the senior citizen market. And the observation is far from encouraging for those in this age group. Automakers typically target campaigns towards young people, families with small children, or executives on the rise, leaving more experienced drivers with generic and often expensive-to-maintain options. The Model 2 deliberately reverses this market logic, placing the senior driver at the center of the project from the very drawing board. Every technical decision, every material choice, and every component was conceived with the specific needs of this group in mind. This is not a car adapted for seniors after it's finished, but a vehicle designed from the first draft to meet this specific demand. The price of $12,749 also needs to be analyzed within the current context of the electric vehicle market, where direct competitors typically cost between $30,000 and $40,000 in the entry-level range. Popular electric models offered by Chinese and European brands have not yet managed to consistently break through this psychological barrier in the American market. Tesla, on the other hand, is betting on a completely redesigned production chain to achieve this cost level without compromising the reliability of the final product. The suggested price places the Model 2 below many used cars from traditional brands and even below the price of premium motorcycles sold today. This aggressive pricing strategy has the potential to completely reshape the entry-level segment of global electric mobility. The choice of targeting the over 55 age group as a commercial priority reveals a precise demographic analysis of who truly has the means and willingness to buy a new car in the coming years. This group represents the largest share of accumulated wealth in developed economies, with stable purchasing power and less sensitivity to long-term financing. Many of these drivers have been driving the same vehicle for over a decade and are reaching the natural point of replacement, seeking something more economical for their stage of life. Retirees and pre-retirees also tend to drive fewer kilometers per year on average, which perfectly fits the characteristics that will be explored in the following points about this model. The combination of low price, a target audience with purchasing power, and precisely mapped specific needs forms the basis upon which the rest of the project was built. All this commercial strategy only makes sense if the car actually delivers on its promised durability, and it is precisely at this point that the engineering behind the Model 2 begins to differentiate itself from any other automotive project ever presented by Tesla. The manufacturing process uses a technique called giga casting, which consists of fusing large pieces of aluminum into a single block using gigantic presses. Instead of welding hundreds of small metal sheets to form the vehicle's structure, the automaker pours liquid aluminum into colossal molds and removes the practically finished piece. This method eliminates welding points, reduces the car's final weight, and drastically increases structural rigidity. The direct consequence is a body that is much less susceptible to twisting, creaking, and misalignment over years of intensive use. Combined with giga casting, Tesla also applies an assembly concept called unboxed, which completely reorganizes how the vehicle's parts are joined during production. In a conventional car, a modern body has approximately 5,000 connection points between its parts, including welds, screws, rivets, and various fittings. In the Model 2, this number drops to about 450 connection points in total. The reduction is so significant that it completely changes the equation for mechanical failures over time. Each point less represents one less place where something can loosen, oxidize, crack, or start making noise over the years. The vehicle's exterior panels also received a completely unconventional approach, abandoning traditional stamped and painted steel for something far more weather-resistant. Tesla opted to use structural polymer on the sides, hood, and doors, a material that combines mechanical strength with lightness and total immunity to corrosion. These parts do not receive conventional paint because the color is already incorporated into the polymer's structure itself. Small everyday scratches practically disappear because the color is the same as the interior of the part. There is no risk of rust in any area of the car, not even in the areas most affected by sea air, salty snow on American roads, or acid rain in large cities. The choice of polymer also drastically simplifies the aesthetic maintenance of the vehicle over the decades, eliminating a series of expenses that more experienced drivers know very well. Expensive bodywork to repair small dents becomes unnecessary in many cases, since the material has a certain flexibility and tends to return to its original shape after light impacts. Complete repaints, which usually cost between $2,000 and $5,000 on traditional cars every 7 or 8 years, are simply out of the equation. The original shine is maintained for much longer because there is no layer of varnish aging under the sun. Automatic car washes, tight parking spaces, and daily use in adverse conditions leave much less visible marks on the bodywork of this model. The entire project was designed to deliver an estimated lifespan of 20 years with minimal maintenance, a number that completely contrasts with the current automotive industry average. Modern cars are designed with a real lifespan of 8 to 12 years in mind before they begin to exhibit significant structural or mechanical problems. Tesla is doubling this expectation by using simpler components in smaller quantities and with materials less susceptible to natural wear and tear. Electric motors have very few moving parts compared to a combustion engine, and the absence of oil, belts, spark plugs, filters, and exhaust systems eliminates most annual visits to the repair shop. The practical result is a vehicle designed to accompany the driver throughout the final phase of their active life, without becoming a recurring financial burden. This same philosophy of simplicity and longevity extends to the heart of the vehicle, and the choice of battery for the Model 2 represents perhaps the boldest technical decision of the entire project. Tesla abandoned the traditional lithium-ion cobalt battery pack, a material that always increased the cost of its cars, and adopted a sodium-ion battery with a capacity between 50 and 53 kilowatt-hours. Sodium is one of the most abundant elements on the planet, present literally in table salt and in the oceans worldwide. This abundance significantly reduces the cost of producing the cells when compared to traditional batteries. The choice also eliminates dependence on rare minerals extracted under questionable conditions in different parts of the world. The vehicle's declared real-world range is between 355 and 370 miles per full charge, which translates to approximately 570 to 595 kilometers at 110 kilometers per hour. This number is impressive because it was measured under real-world road conditions, with the air conditioning on and at highway speeds, not in optimized laboratory tests. For most drivers over 55, who typically make short urban trips during the week and occasional weekend journeys, this range easily covers several weeks of use. A driver who travels an average of 50 kilometers per day would only need to recharge the car once every 10 or 12 days. The range anxiety that so frightens those who have never owned an electric car practically disappears in this usage scenario. The cost of home charging is where the savings really become tangible in the owner's pocket, and the numbers are almost uncomfortable to compare with the reality of combustion engine cars. Recharging the Model 2 battery in a common household outlet costs between $8 and $11 per week, considering the average use of a typical driver. The same trip in a gasoline sedan requires between $60 and $70 weekly in fuel, depending on the price of fuel in the region. The monthly difference exceeds $200, and the annual difference easily surpasses $2,500. With fuel savings alone, the driver practically pays an entire installment of the vehicle financing every month. Another interesting detail about sodium-ion batteries is their thermal behavior, which offers significant advantages over traditional lithium cells when it comes to safety. This type of chemistry is much less prone to spontaneous combustion and offers greater stability at high temperatures, a recurring problem in older lithium packs. Lifespan is also benefited by this chemical stability, with expectations of maintaining more than 80% of the original capacity even after thousands of complete charge and discharge cycles. For those who intend to use the car for a decade or more, this behavior ensures that the range will not drop drastically over time. The battery does not need special care to preserve its health and can be charged to 100% daily without noticeable damage. There is an important point that needs to be considered by those who live in very cold regions, since the sodium-ion chemistry exhibits greater sensitivity to extremely low temperatures. In conditions of intense cold, below -10 degrees Celsius, the range can drop between 25 and 30% compared to the official figure. This means that a driver in the harsh winter of Nordic regions or the northern United States can expect approximately 400 kilometers instead of the usual 590. In regions with mild or tropical climates, such as most of Brazil, this limitation simply does not appear. For the vehicle's target audience, who usually live in places with less severe winters or who drastically reduce car use on very cold days, this aspect represents a manageable inconvenience within their daily routine. Thinking about fuel economy and durability would be meaningless if the driver had difficulty simply getting in and out of the car every day, and it was precisely this concern that guided the ergonomic choices of the Model 2. The doors adopt a concept called butterfly, opening upwards instead of sideways, as in conventional cars. This type of opening eliminates the need to bend excessively or contort the torso to access the seat, a movement that often bothers people with back or knee pain. The door sill, that is, the step that separates the floor from the interior of the vehicle, is only 17 centimeters high. This number represents half the height of the sill in the Model Y and makes entry almost as natural as sitting in an armchair in the living room. Biomechanical studies conducted during the vehicle's development demonstrated that the combination of butterfly doors and a low sill reduces the lumbar rotation required to enter the car by 70%. For those who have never paid attention to this detail, this rotation is precisely the twisting movement of the spine that causes the most discomfort in people with herniated discs, osteoarthritis, or simply natural wear and tear of the joints. In traditional cars, the driver must first sit sideways in the seat, then rotate their torso, and finally position their legs inside the passenger compartment. In the Model 2, the movement resembles sitting facing forward in a regular chair, with the legs entering naturally without the need for twisting. This simple redesign transforms the daily experience of those who use the car several times a day for everyday tasks. The vehicle's external dimensions were also designed to make life easier in dense urban environments and tight parking spaces, places that often generate anxiety in more experienced drivers. The Model 2 measures approximately 4 meters and 20 centimeters in total length, placing it in the category of easily maneuverable compact hatchbacks. The turning radius is only 10 meters and 40 centimeters, allowing complete U-turns on narrow streets without the need for additional maneuvers. Parallel parking in tight spaces becomes a smooth operation even for those who have never had much skill with parallel parking. Standard-sized residential garages accommodate the vehicle with enough room to open the doors and unload groceries without complications. The interior controls represent perhaps the most sensitive point in Tesla's decision to break with its current pattern, reverting to a choice that often frustrates older drivers in other models of the brand. The climate control features real physical buttons with different textures for tactile identification, instead of the traditional touchscreen adjustment found in the Model 3 and Model Y. The heating, ventilation, and air direction controls can be operated without taking your eyes off the road, a crucial feature for those with slightly slower reflexes. Rotary knobs for sound volume and traditional temperature selectors bring back the familiarity of cars from past decades. This hybrid approach combines the modernity of the digital dashboard with the practicality of analog controls where they truly matter. The seat height has been calibrated to be significantly higher than the average compact hatchback, a feature that makes a huge difference in the daily lives of those who have difficulty getting up from low surfaces. The driver practically slides out of the seat instead of having to push their body up using leg strength. External visibility also benefits greatly from this additional height, allowing for better visibility of surrounding traffic, identification of obstacles in parking lots, and more accurate distance estimation. Larger than standard rear-view mirrors and thinner front pillars complete the enhanced visibility package. Each of these adjustments may seem small in isolation, but the combination completely transforms the relationship between the more experienced driver and the act of driving every day.